All right, inverse trig functions. So today we're doing compositions of inverse trig functions, which is can be tricky. So normally, inverse functions obey this property, right? The inverse of f of x is equal to x, and similar for the opposite. Right? This is true for normal inverse functions. Unfortunately, this is not always true for inverse trig functions. And why is that? Anybody know?
Because it's only like a certain area of the graph.
Yes, that's close. The reason is that arcsine is not actually the inverse of the sine function. The sine function doesn't have an inverse. And arcsine is the inverse of our restricted sine function, which is a different function, right? And so this is actually not true. Sometimes true, but generally not true. Arcsine of sine of x, let's write theta instead. Arcsine of sine theta is generally not equal to theta, unlike other inverse functions. Yeah, Jaden?
There's no curve on the test quiz?
No.
No?
I might do some similar thing to the unit circle quiz 1, where like if you do better on the corresponding section of the test, then maybe some adjustment. But no curve.
Well, what was our average?
I sent it to you guys, right? Anybody remember?
Yeah, it was the same.
76-ish, 75, 74?
Isn't that pretty bad?
It's pretty bad, yeah.
So, like, we can't have a curve.
If the test was that average, I would curve it. But it's just a quiz, and frankly, you guys should have done better, so I don't think it was my fault. What do you mean?
The average that you're saying is different from the quiz we took last time.
Last class's quiz. I'm pretty sure the group quiz's average was much lower. Yeah. Okay, so this is generally not true for inverse trig functions. Okay, so be very careful not to make the mistake. Let's start with these kinds of compositions. Say we have sine of arcsine of x. Okay? The good news, guys, quiet please. The good news is that this is usually equal to x. Always equal to x unless x is outside the domain of arcsine. Outside the domain of arcsine, which you might encounter a few of those on the homework. So we can do a few examples and see that this is true. So let's do, for example, sine of arcsine of 1/2. Okay, anybody want to calculate arcsine of half?
Pi over 6.
Pi over 6. Thank you. And then what is sine of pi over 6? 1/2. Sine of pi over 6. 1/2, right? Okay. If you utter degrees again in my class, I'll be mad. No more degrees, okay? Degrees are not used in math. If I were teaching physics, degrees only, right? Fine. But this is a math class. Okay, we'll do another example. What is sine of arcsine of minus root 3 over 2? What is arcsine minus root 3 over 2? Anybody?
Five pi over 6.
Negative pi over 3. Negative pi over 3. Okay, you can draw the unit circle. We're looking for a point with y value minus root 3 over 2. So that's here. Bro, what is this? It's here and here. So that's only this point is within the domain, or the range, right? So that would be negative pi over 3. And then, of course, sine of minus pi over 3 is simply minus root 3 over 2. So this rule is good. But on the other hand, for example, sometimes on the homework you might see, oh, what is sine of arcsine of 2? That doesn't exist because 2 is outside the domain of arcsine. There's no value of sine that could give you 2. And so that doesn't exist. So this is true, and that's also true for cosine and tangent. So cosine, arc cosine of x is also equal to x, unless it's outside the domain. And then tangent of arctan of x is equal to x. And that one always works because does it always work? It does always work, because the domain of arctangent is minus infinity to infinity. All real numbers. So no problems with it. Yeah. Daniel?
Why would you write arc cosine or arc sine when you could just write sine to the -1? Isn't that a lot easier?
I prefer arc cosine.
Just a preference?
Yes. It's ow.
But it's fine just to write sine to -1.
I'm okay with that, yeah. It's easier to type for me, arc sine, arc cosine. Okay, so remember the order, okay? This only works for sine of arc sine. The reverse is not true. Arc sine of sine, that does not apply. Anybody want to come up with a mnemonic for us that I can put into the video? How to remember that this only works for sine arc sine? Okay, just remember, the arc is always in the middle, okay? In order for it to work.
Wait, it doesn't work with the other two?
No, what I mean is that this does not work,
Oh, okay.
okay? So if the arc comes first, does not work. Only works if it's in the middle.
How about like
I have no idea if that makes sense.
sin exists, but the cosine does not exist?
What?
Dude, don't need to religionify everything.
Okay.
Wait.
All right, let's just keep going. You guys can remember it by yourself.
Can you go for like 5 more seconds?
5, 4, 3, 2, 1. Let's do the reverse now, and I'll show you guys why it's not true. Okay, so it doesn't work if the arc comes first. So let's say we have arc sine of 3 pi over 4. Now, if you were foolish and didn't listen to the lecture, you would write 3 pi over 4. But we are not foolish. We listened to the lecture, except those of you who are busy fooling around. Okay, let's calculate. Okay, let's calculate sine 3 pi over 4 first. What is that? Anybody?
Does not exist.
No. Oh my gosh. Anybody?
Is it 1/2? Oh, wait.
This is the stuff I told you guys to be able to do in 5 seconds, right?
-2 over.
Negative 2 over 2.
I said before.
Wrong.
Root 2 over 2.
Yes.
Positive 2 over 2.
After the 5th try. Sine 3 pi over 4 is root 2 over 2. Unit circle right. We are right here. That's root 2 over 2. All right. Okay, so then what would arc sine root 2 over 2 be? Anybody? Arc sine of root 2 over 2. No. Okay, we're looking for a point on the unit circle within this range that has a y-coordinate of root 2 over 2. That's this point.
Pi over 4.
Okay, so that's the answer. Notice how that's not the same as 3 pi over 4, right? Why did that happen? That's because of the restricted range of the arcsine function, right? 3 pi over 4 is outside the range of arcsine, so we couldn't have 3 pi over 4. It becomes pi over 4 instead.
Could you also do it by minus pi? Or pi? Was it,
No.
1 or
No.
pi?
Does not work. I'll show you why. Let's do another example. What is arcsine of sine of 5 pi over 6? Okay, first, what is sine 5 pi over 6? Anybody?
What over 2?
Thank you. 1 over 2. Okay, and then what is arc sine of half? It's we're looking for a point within this range that has a y-coordinate half, so that's here. So that's pi over 6, right? So once again, that's actually different. So as a general rule, when this is outside the range of arc sine, it's not going to give you that answer. It's going to give you something else.
As a general rule, can you just take away the coefficient of the?
No. Nope. Liam.
Does it always have a common denominator?
Probably, yeah. Okay.
It just happens that you can, in this case, just take away the coefficient of pi.
Well, the reason that is because everything within the that works for all the multiples of pi that we know. It just happens to.
So for what we've done so far.
Okay, I'll give you another one. I found a counterexample. What is arc sine of 5 pi over 4? Okay, what is sine 5 pi over 4? No.
Negative 1 over 2.
Negative 1 over 2.
Oh,
Negative square root of 2 over 2. And then what is arc sine of negative square root of 2 over 2? It's actually minus pi over 4. So
you can take away the coefficient and then put a subtraction, put a negative sign for it.
when? When do you put a minus sign?
When it's greater than pi. Right?
Yes, but what if I gave you another one? What if I gave you 11 pi over 4?
Okay, use the period method, okay, and then just use the coefficient hash.
Okay, what is sine 11 pi over 4?
Where 11 pi over 4 is equal to 3 pi over 4.
11 pi over
So
4,
it's pi
yes.
over 4. I'm calling it pi over 4.
Yes, it's pi over 4.
Oh my
But at that
God.
point, you might as well just use the actual, do it for real, right? Okay, let's do some examples with cosine, since this seems to be fine. Let's do arc cosine of 7 pi over 6.
Negative root 3 over 2.
No. Oh, sorry, cosine is that, yes. Yeah.
What do you say?
I thought you were writing the answer. Okay, cosine 7 pi over 6, where's that? That's right here, so that's minus root 3 over 2. So we're looking for arc cosine of minus root 3 over 2. That's not pi over 6. It's actually 5 pi over 6. Right? Why is that? That's because for arc cosine, the range is in quadrants 1 and 2, right? So we're looking for something with x-coordinate minus root 3 over 2, so that'll be right here. Okay, that's 5 pi over 6. So once again, it's different. Can't just write that. Give you guys another one. Yeah, question?
So the one above it for arc sine 5 pi over 4, why can't you just write, instead of negative pi over 4, why can't you write 7 pi over 4?
Because that's outside the range of arc sine. Arc sine is minus pi over 2 to pi over 2, right? So even though 7 pi over 4 is in quadrant 4, it's not within the range because it's greater than pi over 2. So arc sine goes from minus pi over 2 all the way to pi over 2. So for instance, a point here, that would be minus pi over 4. Even though technically it's also 7 pi over 4, that would be too large. Okay?
So would you mark us off points if we got the right answer with the coefficient hack on the test?
No.
No?
I don't think it helps you that much, honestly. Okay, let's do another one. Cosine minus pi over 4.
Negative root 2 over 2.
Good? No, Wrong, actually. Sorry. Positive root 2 over 2. All right, and then what is arc cosine root 2 over 2?
No, wait, pi over, that would be positive pi over 4.
Good. Remember, no degrees. Okay, so that's pretty straightforward if you understand the inverse trig functions. If you're in doubt, ever in doubt, just always make sure to compute the inside and then the outside. Don't try to take shortcuts and you'll be fine.
You do one more.
Yes, I'll do tangents starting from now. We have a little more, but it's almost done. Let's do arctangent of 3 pi over 4. Okay. What is tangent 3 pi over 4? Good. You can use my slope trick. Right? 3 pi over 4 is right here, right? And so all I do is just think about the slope of this line, -1. Okay, so what is arctangent of -1? No.
3 pi over 4.
No.
Wait, what's the range?
Minus pi over 2 to pi over 2. Same as sine. Okay. It's only this point and this point, but our domain is this, right? So it's minus pi over 4.
Wait, so it's the same as sine.
Same domain. Almost.
So if it's not within the first or fourth quadrant, you put a negative sign and then take away the coefficient.
I don't know what you're saying. Let's do a trickier one. 29 pi over 6.
So
Arctan tangent.
That's 5 pi over 6.
Really?
minus 24 pi is 5 pi over 6.
That is wrong. 5 pi over 6 is outside the domain. But you're good that 29 pi over 6 does reduce to 5 pi over 6. Okay, good. So 29 pi over 6 minus 4 pi,
Negative pi over 6.
right? We're allowed to do that because 4 pi is a multiple of 2 pi. If we had subtracted 5 pi, that would be wrong because it's not a multiple of 2 pi. So 6 pi is good. 6 pi works. So this tangent,
Yeah, negative pi over 6.
this is true. And then tangent 5 pi over 6 is? Tangent 5 pi over 6 is minus root 3 over 3. And then arctangent of minus root 3 over 3 is minus pi over 6. I did go through that a little quickly, but you can check that for yourself. All right, so any questions? All right, then let's continue on to compositions of inverse trig functions that are different. So, for example, let's say we had sine of arc cosine this time of 3/5. These are actually very easy, don't worry. Okay. What you would do is, the best way to actually think about it is by writing some kind of intermediate variable, theta, and setting that equal to arc cosine of 3/5. So in the end, all we're looking for is sine theta, right? But if we know that this is true, that simply means that cosine theta equals 3/5, right? Yeah? And all we need to do now is draw a triangle that corresponds to that. So if this is theta, then adjacent is 3, hypotenuse is 5, this is 4, and so that means sine theta is equal to 4/5. And we've actually done this kind of problem before, haven't we? On quiz 2, right? I gave you sine theta equals 4/5. Told you theta was in quadrant 1. Asked you to find cosine theta. Okay, let's do a more tricky one. Let's say we had tangent of arc sine, but this time we have a negative value, say negative 3/5. Okay, we're going to do the same process. We set theta equal to arc sine minus 3/5. So that means we're simply looking for tangent theta. But if theta equals arc sine negative 3/5, that simply means that sine theta is equal to minus 3/5. But now we have to be very careful and think clearly about which quadrant theta is in. I changed my mind. Let's do cosine instead. Sorry if you're writing on paper. Okay, we have to think very clearly about where theta is. So if arc sine is of a negative value, meaning that sine theta is negative, and theta is within the range of arc sine, then which quadrant would theta be in? Right? Nope. 4. Good. Why is that? That's because in quadrant 4, sine is negative, because we have negative y values, but that's also within the range of the arc sine function. Whereas if theta was in quadrant 3, sine would also be negative, but that's outside the range of arc sine, right? So that's impossible. So that means that theta is in quadrant 4, which means that the triangle we draw must look like that. So if this is theta, then and arc sine is, or sine theta is minus 3/5, then that means that this length must be minus 3, and this length must be 5, right? I know that this is negative because we're on the negative side of the x-axis. Okay? So that means this is positive 4. Why positive? Because it's in that specific quadrant, right? Has to be positive. So that means that cosine theta is equal to 4/5. Note that it's not equal to negative 4/5. If you had not listened to this lecture, then you might have thought that theta was in this quadrant. But that would have given you a negative value of cosine, right? Which would have been wrong. Wrong. That's what I said when I was grading your quizzes last time. Wrong. Just kidding. That was insensitive. Okay, any questions? Do another example. Let's say we had tangent of arc cosine. Wait, no. I wrote it wrong. Wait, no, I did write it right. Tangent of arc cosine minus 2/3. Okay, easy one. Once again, we have to think very clearly about the quadrants. So let's say theta equals arc cosine of minus 2/3. That means cosine theta equals minus 2/3. And we're looking for tangent theta. Okay? Well, which quadrant would theta be in? Any ideas?
3, 3rd.
Nope. Second. It's in the second quadrant because for the arc cosine function, the domain is quadrants 1 and 2, right? And in order for cosine to be negative, it has to be either quadrants 2 and 3. And so therefore, theta must be in quadrant 2. Okay? So theta has to be here because that's within the range of arc cosine, and that gives us a negative cosine value. And if cosine theta is minus 2/3, then that means that this length is minus 2, and this length is 3. All right, hypotenuse is always positive. All right. So what is the remaining length? Anybody?
4.
Root 5. Pythagorean theorem, right? Root of 9 minus 4. So our answer is tangent theta equals, well, that's not theta, is it? This is theta. But tangent theta equals negative root 5 over 2. That's our answer.
What is that?
Well, theta we define always starting from the positive x-axis, right?
They're Jordan 4s.
Any questions? Okay, sometimes you might also encounter things where we have variables. Don't worry, they're very easy. Say we have maybe, let's do secant this time. Secant of arc tangent of x. Okay? Now this looks hard, but all we do is do the same process as before, except with x as a variable instead. So once again, we're going to set theta equal to arc tangent x, which means that tangent theta equals x this time. And we're looking for secant theta. So good news, when we have a variable, we can just make our life easier and just assume that it's in the first quadrant. And our results will generally hold. So if tangent theta equals x, tangent is opposite over adjacent, so we'll call this x and call this 1. That means by the Pythagorean theorem, the hypotenuse is x squared plus 1. And so secant theta equals hypotenuse over adjacent, which is x squared plus 1. Okay? You will encounter this a lot at the tail end of calculus when you guys do more complicated integrals. You'll have to use inverse trig functions. And you'll have to do this process in reverse. Yeah,
Why
let's
is
enjoy.
the hypotenuse x squared plus 1? Isn't it plus y squared?
I use the Pythagorean theorem with 1 and x. Yeah.
Oh. Wait, how do we know that the y is 1?
What do you mean the y is 1? X doesn't correspond to any axis. It's just a variable in the equation. And so if tangent theta equals x, then this has to be x and this would be 1. Okay? This is just a generic triangle. It doesn't correspond to any unit circle thing.
Can you use the restroom?
Yes. Any other questions? Did we want to see one more example, or is this too easy?
Do you believe in the rapture?
Let's do one more. No.
The rapture? When all the Christians
I don't believe in a pre-millennial pre-trib rapture.
blown up into heaven or the